Okay, so I'm just going to go through a few exam questions on the calculations for momentum, because I know that this is quite a challenging part that some people find. So I've picked out there's 4 different calculation questions. I will also send these questions to you if you want to have a go at them, but I'm going to work through them and then you can see how they can be answered. So the first one then, which comes up quite often, is this collision. So you've got 2 different cars, you've got a van and you've got a car. It gives you information about the mass and the velocity before the collision, and then it's asking you to work out the velocity after the collision. Now it's the same steps for all of these questions really if you follow them, and I'll show that to you by doing the same steps for each and every question. So the question asks here to calculate the velocity of the 2 joined cars immediately after the collision. Now, the equation that you're going to need to use, and you're going to need to use for all of these, hopefully you know, P being momentum equals M being mass multiplied by V being your velocity. Okay, so that is the equation that you're going to use. So P equals mv. Now in this we've got a before situation here and we've got an after situation here. So to set out your work, it's probably easier to have before and after. And remembering that the momentum before is always the same as the momentum after a collision. We've also got 2 things. We've got a van and we've got a car. So if we just write that out as well. And then we're going to work out the 3 different things. We're going to get its mass, its velocity, and its momentum. So I just write down the side, mvp, so the masses, the velocities, and the momentum. Then we can start filling this stuff in. So we know that before the collision, the mass is 1,500 for the van. For the car, we know it's 900. Our velocity, before, if we look up, it's 8. And then for our car, it's 0. We then need to work out the momentum of these 2 things. So 1,500 multiplied by 8 will give you 12,000. And then anything multiplied by 0 is just going to give you 0. So our total momentum before is going to be 12,000. If we look after then, our mass after, well, the mass of each thing isn't going to change in a collision, so the masses are still the same. The velocity we're unsure of. They're now joined, so that's going to be the same for the van and the car. The velocity will be the same because they're joined now. So essentially we could join up their mass as well. And we know that the momentum before is the same as the momentum after, so we just put that value into here. So momentum is going to be 12,000. We can then work out our velocity. So using the equation P equals mv, we just need to rearrange that to find V, our velocity. So V equals P divided by M. Velocity therefore is 12,000, which is our momentum, divided by our mass, which is 2,400. That should give you a velocity then of 5 meters per second. So lay out like that. I know it seems a lot of work, but if you lay it out like that, you can follow it through step by step, and there you get your answer for that first question. Second one then, again another common question is a skateboarder. So here we've got a skateboarder, and the skateboarder is jumping forwards off of his skateboard. At this moment they are stationary, and then what happens is the skateboard here is going to move backwards, the skateboarder is jumping forwards, and you're given some information about masses and velocities, and you're asked to work out the velocity of the skateboard. So again, we've not got a collision this time, so don't need before or after, but we've got 2 things in this. We've got the skateboard and we've got the skateboarder. Okay, the 2 different things. we're going to want to know the mass, the velocity and the momentum. So you can write those out. Now look back through the question to the bits that you've got. So the mass of the skateboard is 1.8. The mass of the skateboarder is 42. We want to know the velocity of the skateboard. So this is going to be our question mark. We know that the velocity of the skateboarder is 0.3. So we can work out then this momentum. So to work out this momentum, we're doing 42 multiplied by 0.3. So we should get a momentum of 12.6. We know that the momentum before is exactly the same as momentum after. So we can put that across. Momentum is therefore on this side is going to be 12.6. We then want to work out the velocity. Again, equation, momentum equals mass multiplied by velocity. Rearrange to find velocity will give you momentum divided by mass. Our momentum is 12.6. Our mass is 1.8. 12.6 divided by 1.8 is going to give you a velocity of 7 meters per second. Again, laying out really simply, putting in the information that you know, remembering that momentum before is the same as momentum after, momentum's equal in these two situations, then you need to work out what is left, rearrange your equation, and there you go, your velocity is 7 meters per second. Next question to go through. So again, different question from different exam paper, but it's got pretty much the same example that we've seen before. Cars, vans colliding. A little bit different here in that they do not stick together. So again, you've got the idea of before and after, and you've got your two different things. The question though is slightly different. They're asking you to use the information diagram to calculate the change in momentum of the car. And that car bit is important. Make sure you read the question and work out what they're actually asking you. So they've made change in bold, so that's a giveaway. And then it's the momentum we're looking at of the car, and the car only. So we're not really concerned about the van at the moment. We want to know the change in momentum of the car. So if we just write down all of our information, again, we've got before, we've got after, we have the car, the van, the car, and the van. If we just write it all out, mass, velocity, momentum, mass, velocity, momentum. Now we look through, we're just basically putting in those values, so we know that the car, 1,200, the van, 3,200. Velocity of the car is 10 meters per second. Velocity of the van is 0 meters per second. 1,200 multiplied by 10 is going to give us 12,000. Anything multiplied by 0 is going to be 0. So the total momentum before, 12,000. After, again, the masses don't change. They're not joined this time, so don't need to combine them. We're told that the velocity of the car is 2. Now, we want to work out the change in momentum of the car. So at the moment, we only need to look at these car columns. So, essentially, what we need to do is work out the momentum in this after point. So 1,200 multiplied by 2 gives us 2,400. We know that before, our momentum of the car is 12,000. After, our momentum of the car is 2,400. So the difference, the change in momentum, reduce to 12,000 minus 2,400, which gives us 9,600. That is our change in momentum of the car, 9,600. So the second part of this question then, use the idea of conservation of momentum to calculate the velocity of the van when it is pushed forward by the collision. So we've got all of this information here, which is going to be able to help us with this question. So you can sort of bring an arrow down, because that's the workings out that we've done partly already. So we want the velocity of this van. We're trying to work out this bit here, this velocity of the van. Again, we know that momentum equals mass multiplied by velocity. We want to know the velocity, which is going to be momentum divided by mass. We know then that the momentum of our van is going to be 9,600 as well, because total momentum is 12,000 here. The total momentum over this side must also be 12,000, because the momentum before and after are always the same. So 12,000, we've already done this bit, 12,000 minus 2,400, it's got to be 9,600. Add those two together, you get your total of 12,000. So we know that the momentum of our van is 9,600. We also know that the mass is 3,200. 9,600 divided by 3,200 is going to give us a velocity of 3 meters per second. Okay, so we've used that information from part 1 to help us with part 2. We know that the momentum before is 12,000, so the momentum after must also be 12,000. We knew the momentum of our car was 2,400, so the difference between 2,400 and 12,000 is 9,600. That's the momentum of our van. We then use our calculation that we've done previously. Velocity equals momentum divided by our mass. Momentum is 9,600 divided by the mass of the van is 3,200. That gives us 3 meters per second for our velocity. Last one then, again, the skateboarder makes a return. So this time one of the skateboards slows down and stops. The teenager then jumps off the skateboard, causing it to recoil and move in the opposite direction. So we've got the skateboarder going this way, the skateboard going that way. The momentum of the teenager and skateboard is conserved. The teenager of mass 55 kilograms jumps off the skateboard at 0.4 meters per second, causing the skateboard to recoil at 10 meters a second. Calculate the mass of the skateboard. So again, we're going to do the same things as we've done previously. There's no before or after, there's not collision here, so we don't need to do that, but we can write out the two different bits that we've got. So we have the skateboard, and we've got the teenager. Again, we're going to want to know mass, velocity, momentum. Fill in the bits that we do know. So a teenager has a mass of 55, jumps off a skateboard at 0.4 meters per second. We don't know the mass of the skateboard, that's what we want to calculate. We know the velocity though is 10 meters per second. So what can we work out? Well, we can work out this momentum over here. So 55 times 0.4 gives you 22. If it's the momentum for the teenager, it must also be the momentum for the skateboard. So we can put that in here. That then means we can work out the mass. So again, we know that P equals mv. Slightly differently, this time we're just rearranging to find mass. So mass equals P divided by V, momentum divided by velocity. Mass then equals 22 divided by 10. And your mass is going to be 2.2 kilograms. Same idea, just working out mass this time. Write down all of the bits that you do know from the question. Work out what it's asking you to calculate. Work your way through, remembering that the momentum is always going to be the same for both things, so you can use the information from that to help you answer this question. Rearranging your equation and then ending up with your answer. Hopefully going through those has helped. These are all different calculations that you will get from momentum in different exam papers, and again they're pretty similar. Cars, skateboards, sometimes you might see roller skates, ice skates, those sorts of things, but it's all the same type of question. Write it out, in a nice little list so that you can follow that through and end up with the correct answer.